Welcome, everyone. First of all, appreciate everybody being in person. I was just telling Rohit that it feels good to see people and talk versus recording in front of a computer like last year. So thank you. And most importantly, we know that the reception is going on. For folks that don't know, please don't exit now. We want to talk to you. But I appreciate you taking the time. Outside, Las Vegas has a lot of stuff, so you guys sacrificed the reception and are here with us. My name is Arati, and I lead our solutions architecture team here at AWS. And joining me today is Rohit.
Hi, everyone.
And so you're here in the right session, AWS Well-Architected Framework for Hybrid Networks. So what we want to do for the next 45 to 55 minutes is give you some of the best practices that we've learned across by working with customers like you. And that's what we do day in and day out, is sit with customers as they plan for their network architectures. It could be migrations, or it could just be building up VPCs and connecting from on-premises, et cetera. We also know as these architectures come up, it can get complex. We've seen architectures where you start with a single data center, and as your application grows or your business grows, expanding into multiple locations like factories, for example, all these IoT devices, or even multiple data centers across different geographic regions. And adding to that is also the mobile devices. So this can get complex, and our goal is to ensure we provide you best practices to simplify this network architecture. We also know, we saw in the keynote today, there's a lot of hybrid services that AWS has helping you maintain that hybrid architecture. What we also think about is as these locations and devices grow, this is not going to change. We're going to have more and more hybrid architectures come into play. And so our vision, especially on the networking side, is as we think about hybrid, we think about it as our edge nodes. It could be a data center is an edge node for us. An IoT device is an edge node. And our mission and vision is to simplify the services that we provide in order for you that you can use in your architecture. We've got a number of services. We'll talk about them today, but also talk about how to use them efficiently. So that's what we're going to be doing today. There's no one architecture that fits all. I'm sure even in your single application, you would have looked at multiple architectures. So we'll talk about different architectural considerations, some of the best practices, and must-know things that sometimes we forget that you should be aware of. And I did mention we have a lot of networking services, and if you are into networking, you should attend Dave Brown's keynote tomorrow. It's got some announcements that's coming up. And so which service to choose for what kind of architecture? We'll talk about that. We're not going to cover all the 200 services, so we are going to provide you QR codes and links to resources as well that you can refer. We're going to frame this talk using the well-architected framework. For those not familiar with the well-architected framework, we've got these 5 pillars: reliability, security, performance, operational excellence, and cost optimization. And they guide us. They provide us design principles for different kind of architectural patterns that you can take. And that's what we're going to be doing today. All our networking services, we're going to be looking at it from this lens. How do we think about reliability? How do we think about cost optimization? So let's get started, kicking off with reliability. As you think about building reliable networks, what does it mean? How do I have networks that can withstand failures, withstand availability zone failures or regional failures, for example? How do I make sure it is available even though there's a failure, and planning for resiliency? We're going to be covering these 4 services: AWS Transit Gateway, Direct Connect, Site-to-Site VPN, and Client VPN, and also some other considerations. There are other services, as I mentioned, but these form the core in terms of connectivity into AWS. And as I talk about connectivity into AWS, let's start with Direct Connect. We've got this architecture diagram that you're going to be seeing pretty much throughout the session as I talk and Rohit talk today. So we've got the AWS cloud, as you know, we've got the concept of regions. You could have multiple regions, and within the regions, you can launch your own virtual private cloud. You can have one, you can scale up to hundreds or thousands depending on your architecture. We've also got the AWS Transit Gateway within the region. We'll talk about more of Transit Gateway in the later slides, but think of Transit Gateway as that centralized hub where you can attach multiple VPCs, and it provides you that routing mechanism between those VPCs now. We also have your on-premises environment on the right side. So most customers start with a single direct connection. So as you can see here, you establish a connection, you have a direct connect gateway, you attach it to the transit gateway, and this provides you that layer 3 communication to your VPCs in the region, back to your on-premises network. While this works great, we want to think about resiliency. Those direct connect locations that you see there, those can be taken down for maintenance purposes. So going back to reliability, we want to architect for that. So if you think about resiliency here, we bring back the same diagram, but I've expanded my direct connect into 2 different locations. So if you're thinking about mission critical workloads, we highly recommend you to ensure you have 2 different DX locations, 2 separate connections that goes into the direct connect gateway, and therefore going into your AWS Transit Gateway, giving you that full connectivity. Moving along the same architecture, as you expand your on-premises, because in the previous slide, we've had one on-premises environment, and that's still a single point of failure. You have a single customer router there. So as you expand into multiple data centers, the same architecture applies. I still have 2 connections going into my region, into my transit gateway. This is good because from a service level agreement perspective, you get 99.9% SLA with this architecture. An important thing, best practice to remember here is you see that DX location 1 and 2. You get that 99.9% SLA as long as one of that direct connect location is in that same home region as your application. What that means is, for example, let's say my VPC on top is in US East 1, Virginia. Direct Connect 1 or 2 has to be in the Virginia location. So that's when you get that 99.9% SLA. What is the maximum resiliency I can do with my direct connects? We bring back the same, but as you can see here, within a facility, within a single direct connect location, I can have multiple connections. So we ensure these land on different routers at the co-location. So even if one of the router goes down, you still have within that co-location resiliency. So this gives you 99.99%, which is our maximum resiliency today. The same concept applies for resiliency is one of your direct connect location has to be in the same parent region as your workloads. The transit gateway that you see within the AWS cloud, that is also matched to that 99.99% SLA that you see here. So this is, from a direct connect perspective, if you have this kind of an architecture, you do get maximum resiliency. And so depending on what your requirements are, whether your workloads are mission critical or not, you can configure your direct connects accordingly. While we're on the topic of direct connect, I do want to clarify something that comes up often as we talk to customers is link aggregation group. So we do support link aggregation group. So you can bundle your 1 gig or 10 gigs into a link aggregation group and use it with your direct connect. The key thing here to remember is this is not, a lag should be treated as a single connection. We don't treat lags for resiliency purposes because it's to a single connection and to a single device. We talked about the SLA. You've got both the 99.9 and 99.99% depending on how many connections you have. The other thing is some of your workloads might not require 4 connections because there's cost associated with it as well. So if there are applications that don't require like 4 connections, for example, you could always use VPN as a backup, But a key thing to remember is, let's say you have a 10 gig direct connect connection and you have a VPN as a backup. There's obviously going to be a decrease in bandwidth because your VPN is not a dedicated connection. It's over the internet. So you'd have to factor in that as you build your network architecture. We've also got a resiliency toolkit that's built in for you. So you can use that resiliency toolkit to figure out what are the different models from an SLA perspective in order for you to achieve either a high resiliency or maximum resiliency. Moving on to the next connectivity option that we have is site-to-site VPN. We've got two different ways of using site-to-site VPN. One is using the AWS Transit Gateway. So from your on-premises environment, you can create an IPsec VPN connection that terminates on the Transit Gateway. The next is a site-to-site that terminates on the Virtual Private Gateway. As we dive into the site-to-site VPN using the Virtual Private Gateway, so from my customer gateway device, this is fairly simple. It's an IPsec VPN connection. You create a VPN connection, you download the config, upload it on your customer gateway device, phase 1, phase 2, and if you're using BGP, should come up automatically. On the AWS side, you can create two different pair of tunnel endpoints, as you can see here from a resiliency perspective. One key thing that we do want to talk about, we'll cover the performance aspect in the third pillar, but equal cost multipath is not supported with this architecture. And this is why as we transition into the site-to-site VPN with Transit Gateway, you create VPN connections. It all terminates on that Transit Gateway. We've made it highly available on our side. And this architecture supports ECMP, so you can load balance your traffic. The next connectivity option is client VPN. We saw all those, like the second slide, all those data centers and mobile devices. As these grows, we've also got requests from customers saying, hey, not all our users connect from our on-premises environment. We also have remote users that need to connect into our application. So we've got the AWS Client VPN. So as customers, you can create a client VPN endpoint, and you select which VPC has your workloads. You select a target VPC. We create the elastic network interface in the subnets that you choose. And then all the traffic coming in from your remote users is terminated on that client VPN. What you could also do as you expand on your architecture is this target VPC could be connected to a Transit Gateway. And that could have multiple VPC attachments. So you've got an end-to-end connectivity between the other VPCs as well. So we talked about Direct Connect. We talked about site-to-site and client VPN. Some of the other best practices to keep in mind as you think about connectivity in a region or building your applications within a VPC is using multiple availability zones to deploy your workloads. This is important because, as you know, a region, the concept of region is it's a geographical facility. It's multiple facilities. For example, US East 1 is a region. We have multiple availability zones. An availability zone can contain a couple of data centers that are connected together. And those data centers can fail, power outages, or any sort of natural disasters. So we do recommend customers to use multiple availability zones. And as you think about, like, for example, we talked about that client VPN architecture. Remember I said you create a client VPN endpoint and you select which subnets you want to use. We recommend customers to use multiple subnets as that attachment point because we create an elastic network interface in those subnets. And then as you think about like that blast radius and separating out your Transit Gateway attachments or the client VPN attachments, always a best practice to use separate subnets for those and have your workloads running in different subnets. And then finally, this is something we forget, like I forget all the time as we think about like designing, is there are specific service quotas with each service, and we're talking about like these 3 primary services that you see here. Some of these are like hard quotas, like these are numbers that we cannot change. So as you build your network architecture, It's important to keep these in mind. I've highlighted some of the important ones that may be of use to you. And with that, we are wrapping up the first pillar. But these are my favorite 3 good white papers that actually goes into detail, much more detail of what I spoke today in this section. And moving on to security. This is core of what we do. I think no matter what role you're in, network engineer or cloud architects, I think all of us want to make sure this is our first priority. So from a networking perspective, we still want to follow the same principles as the security cloud adoption framework. We want to think about how do we think about identity and access management from a networking perspective, or how do we detect vulnerabilities or detect anomalies into my architecture? How do I protect these, both at the infrastructure layer and both at my application layer? And then finally, like, how do I take care of incident response? Starting with identity and access management. There's a couple of key things, and we're going to go into some of the details about these 3 things. The first is the principle of least privilege. This should be like the de facto. Your networking teams, for example, will have higher privileges for like the hybrid, like direct connect, deploying a direct connect connection, or modifying route tables, for example. Your other teams might not need those because these are resources that your networking teams are creating. The next is that blast radius I talked about. Always good, especially when you create these VPN connections, and as you think about a multi-account strategy. Good to have all your networking resources separate from all your other application workloads. You don't need to have your data warehousing cluster and your other networking components in the same account. Just preventing the that's keeping that blast radius really like small. And then we've also got finally, like from an automation perspective, utilizing AWS landing zone. So for those of you not familiar, you've got blueprints that deploy multi-account or multi-VPC. These are already built-in blueprints that you can utilize and use Control Tower to automate it. When I talked about that blast radius, this is what I meant. So your management team, or teams that manage like your identity and access management, those can go into a separate account. Same thing for your log archival. This is probably you're going to touch it once in a few months, or like when you detect anything. That can go into a separate account. And then your workloads, dev test goes into a separate account, production workloads go into a separate account. And then finally, all your networking resources can go into a different account. From a permissions perspective, it's very important, especially those delete API calls, who has access to those. So you've got IAM, you've got roles, IAM roles, that lets you control who can have access to those delete APIs. You don't want somebody deleting a direct connect connection. That's going to be brutal. Assuming we talked about reliability and you have resiliency in place, but it's important to ensure that your permissions management is really strict, and you also tag your resources, no matter if it's networking resources or any resources. We'll talk about that identity detection and automation, and tagging becomes really critical at that point. We talked about least privilege, and as you think about detection, we've got a number of logs for your VPC. These could be like flow logs, or these could be DNS logs or CloudTrail logs. All these logs give you some level of information about traffic entering your VPC or exiting, or any denied request, for example. Your CloudTrail logs are going to show that. The good thing is the flow logs, for example, is integrated with GuardDuty. So what it can do is you can set up threat detection. And once you know if there's, depending on what level of threat detection you set, and you have your findings, you can now send this to AWS Security Hub, where you have a fully comprehensive view of what's happening, and then think about how do you want to remediate it and automate remediation. This could be using like partner solutions that's available, or using any automations that you use today, even on premises. From an infrastructure protection, we have a couple of options for you. These are basic but very powerful options. Security groups. At an instance level, this is like your basic, I would say like a basic weapon to say, hey, what's permitted and what's not permitted. And then at your subnet level, you have network access lists that is actually stateless, so you'll have to define what is allowed inbound and what is allowed outbound. And then you have, once you finish your instance and subnet, you want to control your routing. So you've got multiple route tables. We talked about like Transit Gateway, which has its own route table. VPC as a whole has its own route table. So you've got these like 4 options that you can play around with to ensure you have the maximum security in place for your applications. We've also got a few other services that can help you with infrastructure protection and detecting vulnerabilities, starting with the Gateway Load Balancer, where you can deploy a fleet of instances to perform like IDS and IPS, for example. And then you've got Network Firewall that can filter traffic that's coming into your VPC, either from your VPN or Direct Connect. And then finally, you've got the Amazon Route 53 Resolver DNS Firewall that can help you prevent against any DNS threats. So you've got these options that are available to you, and you can use it in combination depending on what you want to achieve with your infrastructure. Moving on to data protection. It's common, we say this all the time. I think Werner says this all the time. It's like encrypt everything, like anytime. From a networking perspective, you can encrypt your Direct Connect connection. You can also use site-to-site VPN, for example. It's encrypted by default. With Direct Connect, you do have to encrypt them. We'll talk about it. And then you can also encrypt your application traffic using TLS or any certification-based authentication. For example, with Direct Connect connection, we launched MaxX support earlier this year for encryption. Because Direct Connect by default, there is no encryption. So we launched the MaxX support earlier this year. From an application, we talked about it, you can use TLS. For layer 3 encryption, especially when you're using Direct Connect and you're using Transit Gateway, you can always use a site-to-site VPN terminating on a Transit Gateway or a software VPN appliance as well. Just drilling down on that MaxX piece that we talked about. So if you look here, you've got the Direct Connect location in the center. You see how the encryption, there is encryption between that customer cage, the router that you see there, to the AWS router. So that could be sitting at the co-location or coming from your on-premises. So this is supported today. It's supported only for 10 gigs and 100 gigs connection at specific Direct Connect locations. This is available on our website where we support it. From a network layer encryption perspective, we take care of this for you. All our traffic that is leaving our facilities are encrypted, for example, between regions. As they leave the facility, it's encrypted. And as you think about some of the services that you use, Transit Gateway, we talked about it a lot in the first few slides. Transit Gateway, when you use it between regions, there's a feature where you can peer transit gateways between regions. That is also encrypted. Same thing with VPC peering as well. So these are things that are automatically available to you. You don't have to do any like extra configuration. We talked about like detection and encryption, right? But incident response is critical. Like, what's the purpose of detecting all this if you're not acting upon it? There's a few services that are available that you can utilize that can help you with incident response. GuardDuty, for example, can monitor your AWS environment, your VPCs, and any networking resources that you're running within that environment. And then as we talked, you can push those logs and look at what's happening and push it to Security Hub to remediate, to say, what do you want to do when such an event occurs? And then finally, you can use EventBridge to automate some of these actions that you want to do. These are some of the resources that you can take a look at from a security perspective. And with that, I will pass it on to Rohit to talk about performance.
Thanks, Aarti. Let's dive in the performance pillar. When customers plan for performance, there are key factors such as bandwidth, latency, and jitter that influence your choice of the hybrid connectivity design model. When it comes to connectivity options, you can choose between AWS site-to-site VPN or AWS Direct Connect connection, or a combination of both. When it comes to AWS regions, when it comes to infrastructure locations, you can choose between AWS regions, AWS local zones, or AWS outpost. And the third thing to keep in mind here is that you should choose the right EC2 instance type that is meeting your application performance needs. Now let's talk about the VPN connectivity options. So you have your on-premises data center on the right, and you have your AWS region on the left and a VPC within it. The first option is to terminate the VPN connection on a virtual private gateway, which goes over the internet. The second option is to terminate the VPN connection on an EC2 instance that is running the VPN software appliance. The third option is to terminate the VPN on an AWS transit gateway, which can itself connect up to multiple VPCs. And a slight modification of this is to use accelerated site-to-site VPN that leverages AWS Global Accelerator to route traffic from your customer device to the closest AWS edge location. Now let's look at the throughput considerations for each of these options as we talk about the performance pillar. In case of the virtual private gateway, you can connect to a single VPC. And with this option, you get 2 tunnels, and each tunnel, the throughput is limited to 1.25 gigs per second. And there is no support for eCMP, as Aarti talked about previously. When it comes to Amazon EC2 instance, you get connectivity up to a single VPC. The throughput here depends upon the type and the size of the EC2 instance that you choose, as well as on the specific VPN vendor that you are using for your software. And same applies for the eCMP. The third option, where you have the VPN terminating on the transit gateway, it can connect up to multiple VPCs. So it simplifies your VPC to VPC as well as your VPC to on-premises connectivity. And the throughput that you get here is 1.25 gigs per second, and it also supports eCMP when you are using dynamic routing for your workloads, and you can get higher aggregate bandwidth for your VPN connections. As we talked about AWS site-to-site VPN connection, the traffic goes over the internet and goes from multiple hops and multiple networks to reach your VPN endpoint. While this is an attractive option due to low cost and easy to set up, keep in mind that the performance over the internet is on a best effort basis and can vary drastically depending upon various conditions such as internet, weather, congestion, etc. One option that customers use when they are experiencing excessive latency and jitter due to internet congestion is to enable acceleration for their VPN connection that terminates on the transit gateway. So as you see in the diagram here, you create an accelerated site-to-site VPN from your customer from your on-premises environment, and the traffic actually enters the nearest AWS edge location. In this case, you have your on-premises data center in the New Jersey location, and when you enable accelerated site-to-site VPN, it connects to the nearest edge location, which is in Newark, and after that, the traffic rides on the AWS backbone, which is congestion-free, to reach your VPN endpoint. When customers run production-critical workloads, we often recommend them to use AWS Direct Connect, as it provides consistent network performance when compared to going over the internet. And when customers go with the Direct Connect, the first thing that they have to choose is choosing the right Direct Connect location to connect to. As seen in the diagram here, you have your corporate data center in the south, and if you connect to a Direct Connect location, such as in Dallas, and then connect to your AWS region, which is in US East 1 region, you get a suboptimal path due to higher latency. However, if you now connect to an AWS Direct Connect location in Ashburn region and then connect to the AWS US East 1 region, you get a better path in terms of the lowest latency. Going back to the laws of physics, latency is directly proportional to the geographical distance, so we recommend our customers to choose a direct connect location that is closest to their data centers in order to minimize the latency as well as the cost. Once you have provisioned your direct connect connection and established a cross connect, there are three ways that you can connect to AWS resources. The first option is to create a private virtual interface directly to your VPC, or you can connect to a direct connect gateway that can give you connectivity up to 10 VPCs that can be in either same region or different region except China. The second option is to create a transit virtual interface that can connect up to 3 transit gateways via a single direct connect gateway. The third option is to create a public virtual interface to connect to public AWS services such as S3. And in all of these options, you can have both IPv4 as well as IPv6 connectivity. Let's talk about how you can scale the bandwidth of your direct connect connection. The first option is to choose link aggregation group. In this case, what you can do is that you create a link aggregation group and can bundle up to 4 direct connect connections that can act as a single managed connection to give you a higher aggregate bandwidth. Now, in this case, keep in mind that we support single chassis lag, and all connections that are a part of a link aggregation group must be in an active mode. So with link aggregation group, you can connect up to 2 direct connect connections that are of 100 gig connections, or you can connect up to 4 direct connect connections if your direct connect speeds are of 1 or 10 gig connections. The second option is to use ECMP. You all are familiar with ECMP here, that you can load balance traffic across multiple direct connect connections using ECMP. And the way you accomplish that is by advertising the same prefixes using the same BGP attributes from your on-premises location to AWS. In this case, if you want to load balance traffic across multiple direct connect connections, you advertise the same BGP community tag to the prefixes to the AWS. So keep in mind that this is applicable for your private and transit virtual interfaces. In case of public virtual interface, the way you can load balance traffic across multiple connections is by sending traffic across multiple connections that are terminating at the same direct connect location at the same region. As you build your hybrid connectivity, there are various scaling considerations to keep in mind. The maximum bandwidth that you can get for your direct connect or your direct connect gateway or your VPC is up to 50 gigs. You can get up to 5 million packets per second for each of your transit gateway attachment. As discussed before, the maximum bandwidth that you can get for each VPN connection is 1.25 gigs per second, and you can get up to a maximum of 140,000 packets per second for each of your VPN tunnel as a part of your VPN site-to-site connection. So far, we have discussed that your infrastructure is running within an AWS region. While this is useful and is applicable to most use cases, there are several use cases where customers require low latency or have a local data processing requirements for their workloads. With AWS Outposts, customers can run AWS infrastructure and services on their on-premises environment in a truly hybrid, consistent manner. And this is useful if they have low latency requirements as well as local data processing requirements. When it comes to AWS local zones, you can run latency-sensitive applications closer to your end users and meet data residency requirements. And with AWS local zones, You can create a private virtual interface leveraging the AWS Direct Connect gateway that allows connectivity directly to your VPC that has the local, with the local zone. So as we talk about the performance section, it is also important that you choose the right Amazon EC2 instance type for your workloads. So we recommend our customers that you choose the newer instance types based on your performance needs. You also have option to enable enhanced networking for your EC2 instances to get higher bandwidth and higher packets per second. You can also choose Elastic Fabric adapter that helps you run HPC applications where you can run applications that require inter-instance communication. Or you can use placement groups. Recently, we made an announcement that you can now drive up to 50% of network bandwidth to various destinations such as your direct connect, your internet connection, or across AWS regions, provided you meet the conditions such as choosing a current generation instance type with a minimum of 32 vCPUs, and the traffic is either directed to direct connect, internet gateway, or other AWS regions. For all other instance types, the limit is still limited to 5 gigs per second. And that wraps up our performance pillar. And here are some of the resources that you can take a look at it. Now let's talk about the operational excellence. In this pillar, we are going to focus on various AWS services and tools that can help you monitor the health of your hybrid network, as well as how you can manage operational events. This will help you understand and how you can drive operational excellence for your hybrid connectivity design models. Let's start with Direct Connect. Direct Connect integrates with CloudWatch to monitor your physical Direct Connect connections. For example, you can monitor the encryption state of your Direct Connect connection, which Aarti just talked about using the connection encryption state metric. You can also monitor the status of your virtual interface metrics as well. You can combine these metrics and build dashboards using CloudWatch, as well as create CloudWatch alarms to notify your operations team in case a particular metric is not behaving as intended. AWS Direct Connect schedules planned maintenance, and we notify you as a part of the personal health dashboard. So we also recommend that you set up monitoring via active probing to detect link conditions such as packet loss, latency that are not detected by BGP but can influence your application performance. And the way you can do that is by creating an EC2 instance within a VPC that constantly monitors your target IP addresses and notifies you, and you can automatically fail over to a healthy link. We also recommend that you enable bidirectional forwarding detection on your customer router in order to ensure that you can fail over faster to another healthy link. Since we are talking about the operational excellence pillar, we also recommend our customers that you can continuously perform failover tests, and you can leverage AWS Direct Connect failover tests, and also set up a backup connection, either that's like a Direct Connect connection or a site-to-site VPN connection to meet your resiliency requirements, and that helps your operational teams to be prepared in case an unplanned outage happens, so you can automatically fail over to another healthy link. Moving on to site-to-site VPN connection. Site-to-site VPN connection also integrates with CloudWatch, so you can monitor your metrics such as the state of your VPN connection, whether it's up or down, or you can monitor the data that is received in and out of your VPN connection. You can also create like a CloudWatch alarm that can help you notify when either one or both of your VPN tunnels are down. And as with operational excellence, we notify our customers like you whenever AWS performs any updates to the tunnel endpoints, or when you modify a particular VPN attribute. If you have configured a single tunnel out of the 2 tunnels that you get when you create a VPN connection, we will also notify you to make sure that you are planning for redundancy there as well. So as we talk about best practices for VPN, we also recommend that if your customer gateway device can support BGP, then you can choose dynamic routing for creating your VPN connection. And you can use dead peer detection to failover from one tunnel to another tunnel. And as a best practice, you should configure both VPN tunnels. Now let's talk about Transit Gateway. Transit Gateway also integrates with AWS CloudWatch, so you can monitor Transit Gateway as well as attachment level metrics. So for example, you can monitor like bytes in and out, packets in and out of your Transit Gateway or your attachments. Transit Gateway also, with Transit Gateway, you can also create an alarm. Like for example, if packet drops is one of the key important metric for you, you can create an alarm for that helps you monitor when the packets are either black holed or it is dropped. You can also use Transit Gateway Network Manager that can help you centrally manage your networks that are built around Transit Gateway. So you can monitor and visualize both your networks across AWS regions as well as your on-premises networks to do that. Transit Gateway Network Manager also has a feature called Route Analyzer that can help you validate the routes that are a part of the Transit Gateway route table. So for example, if you're connecting to on-premises environment over DX or VPN, you can see what type of routes that are being injected in the Transit Gateway route table and can help diagnose any route-related issues that could be disrupting your global networks here. So far, we have talked about monitoring your hybrid resources. Now, let's also understand that it is important that you also monitor the network performance of your Amazon EC2 instances. And this is important if you are troubleshooting like instance performance issues. For example, if your instance is dropping packets, you need to know why the instance is dropping packets. It could be due to like a traffic spike. So you can monitor various metrics such as the maximum bandwidth that is allowed for your inbound and outbound traffic, or you can monitor the packets per second, the connection strat, or the various instances that could be hitting your link local addresses, for example, such as your instance metadata service, your NTP time sync service. And as we wrap up our monitoring session here, it is also important that you define a IP addressing scheme to make sure that you do not have overlapping IP addresses across your VPCs as well as your on-premises environments. And this is really important so you can ensure that you have the efficient utilization of your IP addresses and reduce the risk of having overlapping addresses. Another best practice to keep in mind from an operational excellence perspective is when you are building your hybrid architecture is to choose a unique ASN for your transit gateways, for your direct connect gateway, as well as for your on-premises environment. And that wraps up our operational excellence pillar. And these are some of the references that you can take a look at it. We recently launched the hybrid networking lens that also goes over with these details. So please feel free to take a look at it. And now let's talk about the last pillar, which is the cost optimization pillar. So we've heard from Aarti and I across the other 4 pillars that you have various connectivity options for your hybrid networking. And while we talk about these hybrid networking architectures, it is also important that you understand the various costs that are associated with these networking architectures to help make an informed decision. So from a cost perspective, let's start with understanding your baseline cost. You have a few options that you see here, and some of which we already talked about. For example, VPC flow logs. You can use VPC flow logs to identify the top talkers and the application traffic going to and from your on-premises environment. We also recently made an announcement that you can now send VPC flow logs directly to S3 in an Apache Parquet format, and that can help you save up to 25% cost in the S3 storage. You can use Amazon Athena to query your VPC flow logs, and you can use the QuickSight, Amazon QuickSight, to visualize the Athena analysis of your AWS cost usage and usage reports to help identify any data transfer cost. So there are various designs that we talked about. So let's start with the first one, where you have your on-premises environment and you create a site-to-site VPN connection terminating on the virtual private gateway. In this model, the data transfer into AWS is free of cost. But you pay for the hourly charge for your VPN connection as well as the data transfer out charge. So in this model, you get connectivity up to a single VPC here. As we talk about terminating a site-to-site VPN connection on the transit gateway, in addition to the VPN charges that I just talked about, you now also pay for the transit gateway charges, and that includes your data processing charge, as well as the attachment charge, which is the VPN attachment that you just created for the transit gateway. Now, in this model, you do not have to create multiple site-to-site VPN connections to each of your VPCs. So transit gateway is really simplifying your VPC to VPC as well as your VPC to on-premises connectivity. You can also choose to enable accelerated site-to-site VPN connection that terminates on your transit gateway. In this case, in addition to the site-to-site VPN charges as well as the transit gateway charges, you now also pay for the AWS Global Accelerator charges, as it uses Global Accelerator, and that charge includes the fixed fee as well as the data transfer out premium charge, which depends in the dominant direction of your traffic. So if you are doing a lot of data transfer out from AWS back to your on-premises environment, customers often consider at Direct Connect due to its lower data transfer out charges. So let's talk about this architecture that involves Direct Connect. In this case, you connect from your on-premises environment to AWS directly to a virtual private gateway or via Direct Connect gateway. There is no charge for Direct Connect gateway itself, and the data transfer into AWS is free. But you pay for the Direct Connect port hour charges as well as the data transfer out charges when sending traffic back to your VPCs. So think about this use case where you are using Direct Connect gateway. It can help you connect up to 10 different VPCs in either same or different regions. Now, when you have a Direct Connect and the transit gateway, so when you have the Direct Connect location as well as the transit gateway in the same region, you can connect that through Direct Connect as well. So in this case, in addition to the Direct Connect charges that we just talked about, you now also pay for the transit gateway charges, that includes the data processing charges on a per gigabyte basis, as well as the hourly charge for your attachment. And in this case, the attachment is going to be the Direct Connect gateway attachment. What if now you have the Direct Connect location and the transit gateway in different regions? Now, in this case, you establish the Direct Connect connection. In addition to the transit gateway charges, and the direct connect port hour charges. The direct connect data transfer out charge depends upon the source region, which is sending traffic back to the on-premises environment. And here's a summary of what we have discussed so far in terms of the various connectivity options. So you can think about this slide as like a summary slide to help you choose the right AWS networking service from a cost perspective. And that wraps up our cost optimization pillar, which is also the last pillar. And here are some of the references that I feel that you can find useful. Finally, as you are building your hybrid connectivity design, please ensure that you take a look at these 5 pillars of the well-architected framework that can help you guide and choose, that can help you guide and implement the best practices. And here are some other sessions that are happening this week, so feel free to take a look at, check them out. And thank you for joining us today. I hope you found this session useful and informative. We would love to hear your feedback on this session so we can help improve how this session is run next year. And so please feel free to fill out the survey and let us know what you think about it. Thank you very much.